Okay, hello year 12s. We're going to start integration, which is your chapter 11. And I thought I'd give you a little bit of an introduction before we do that. So in just to recap, you have learned integration in your AS course in book 1, but you only looked at the very basics of integration. And you also learned that integration is just the reverse of differentiation. So from chapter 9, you saw that if you differentiate sine, you will get cos. If you differentiate cos, you will get minus sine. Okay, and if you differentiated e with the power, you will get, k, e, kx, if kx was the power of e. And if you were to differentiate a function with natural logarithm or ln x, for example, then you would get 1 over x, okay? So integration would just be the reverse of these. So if you had a function which had x in the denominator, and if you wanted to integrate that, you will get ln. If you wanted to integrate cos, you will now get sine. And if you integrate sine, you will now get minus cos. Okay? So here are the new rules. Okay? So this is the basic of integration. You learned this in book 1. Okay? Where if you've got a function in x with a power, how would you integrate it? You would increase the power by 1 and you would divide it by the new power plus the c. Always have to add on the constant. Okay? If you've got e to the power x, but if that x has got a coefficient of 1, then that integrates to ex plus a constant. Okay? If you've got 1 over x now, and if you integrated that, you will now get natural log. And just let me quickly go through why that is. Okay? So if you had a function 1 over x, and if you wanted to integrate that, you would write this as x to the power minus 1 dx. Now, if you were to integrate using your basic integration rule, you would be doing this, adding 1 and dividing by the new power. Obviously, we can't do that because you would get a 0, and you can never divide by 0. Okay? So that doesn't work. Okay? That is why we end up with a function in natural logs. Okay? Alright. Also, there is another connection where, if you were looking at, so if you were to differentiate a function in ln, you would get 1 over x. Basically, if you were to draw the graph of ln x, now I'm explaining this using differentiation. So this is a graph of ln x. And if you were to plot its gradient function, you will then end up with a reciprocal function, okay? Which is why this works, okay? But you don't have to know why it works. You just want to know what it is, what 1 over x integrates to, and what ln x differentiates to, okay? Next, I've already been through cos and sine, so these are just reverse of your differentiation functions. Now, these are some of the new functions that they've added in, okay? So all you've got to do is just remember, some of these are given in your formula booklet. I think all of these are given in your formula booklets. So sec square integrates to tan, cosec x cot x integrates to minus cosec, cosec squared x integrates to minus cot, and sec x tan x integrates to just sec x. Okay, so we've got to keep these in mind when we are going through our integration questions. Okay, so I am just going to go straight into example 1, which is on page 294. Okay, and it asks you to find the integrals of these functions. So we've got 2 cos x, there's a bracket here, plus 3 over x minus root x. Okay, and you've got to integrate this with respect to x. So the cos x, so if I go back to my list, and if I look, cos x integrates to sine x, so this first function here, this first term, is going to become 2 sine x, plus I've got 3 times 1 over x, so that's just going to integrate to 3 ln x, minus root x, that's just minus x to the power of a half, so that is going, so that's just from your book 1. You would be able to do that, you were able to do that from AS. So you would add 1 to half, you get 3 over 2, and you would divide by the new power, okay, which is 3, and your 2 comes here, plus c. So final answer, 2 sine x plus 3 ln x minus 2 over 3 x to the power 3 over 2 plus c, and the ln and the x, you've got to put it in modulus, and the reason for that is that you can't have a negative, you can't take a negative natural log of, you can't take a natural log of a negative number, okay. Part B, you've got cos x over sine squared x minus 2e to the power x dx. Okay, now this looks a bit scary, obviously, because you haven't learned any rules for a fraction, on how to integrate a fraction. So what I'm going to do is I'm going to try and simplify that, okay? And if I was to simplify that, I could rewrite this as cos x over sine x multiplied by 1 over sine x. And I'm going to leave that as it is. I'm not going to integrate it yet, okay? Now cos over sine, you know what that is. That's going to be cot x. And you know that 1 over sine x, that's cosec x. Okay, so once you've simplified that, go back to your list, the list that they've given you, and you know how to integrate cot x, cosec x. Okay, so that just integrates to minus cosec x. So that is going to be my integral of cot x cosec x. So that goes to minus cosec x, and 2e to the power x is just going to go to 2e to the power x plus c. Okay, so that is going to be your final answer there. And then quickly look at example 2. And example 2 says, given that a is positive, or a is a positive constant, and the integral of 2x plus 1 over x for the limits between a and 3a is ln 12. Find the exact value of a. Find the exact value of a. Okay, so what I'm going to do is I am going to integrate this, put in the limits which you've learned from book 1, make it all equal to ln 12, and then solve my equation. Okay, so if I'm first going to split this up like this, okay. If I then simplify it further, I'm going to get 2 plus 1 over x dx. If I then integrate it, I am now going to get 2x plus ln x, and I've got the limits there. I'm now going to put in the limits. So the bigger limit goes in first. So I've got 2 times 3a plus ln 3a minus 2a plus ln a. Okay, and all of that is equal to ln 12. Okay, simplify it. 6a plus ln 3a minus 2a minus ln a equals ln 12. That's 4a plus ln 3a minus ln a equals ln 12. And if you remember from your log rules in chapter 14 of your book 1, okay, that if you've got a negative sign, it means division of these two terms. So you can simplify that by writing it like this. So this comes down to 4a plus ln 3 equals ln 12. And now we just have ln 12 minus ln 3. So 4a equals ln 4, using again our division rule there. And then a is equal to a quarter ln 4. Okay? So that's your example 2 done.